Hi, and welcome to this quick look at the connection between melting points of metals and the strength of their metallic bonds. So we'll start off by doing a quick review of what metallic bonding is actually about. So this little animation shows you the electrostatic attraction between metal cations and delocalized electrons. So we put a positive charge on each of those cations. This would obviously represent a group 1 metal. Obviously group 1 metals will produce a 1 plus cation, losing one outer shell electron. If you went to group 2, it would be 2 plus, group 3 would be 3 plus. So let's have a look at the consequence of these different charges as you go from one group to the next. So looking at these things that change, first of all, the ionic charge increases. That means there's more electrons lost from the outer shell. So that means the difference in the total negative charge in the atom compared to the total positive charge gets bigger. So in other words, the number of protons stays the same, but the number of electrons that have been lost increases. So that means the ionic charge goes up. The ionic size decreases because there's now increased nuclear attraction for the electrons that remain. So this pulls the electron shells closer. So you can see the circles representing the cations get very slightly smaller. So if I can just illustrate, if I take sodium, slightly larger radius, magnesium, slightly smaller radius, and aluminium, slightly smaller radius still. So what happens is you get a greater charge, but it's concentrated into a smaller volume, a smaller size of ion. So this gives us something called increased charge density. Now the consequence of this is twofold. The strength of the electrostatic attraction between the cations and the delocalized electrons goes up, and at the same time the density of the delocalized electrons increases. You can see in the picture for aluminium there's actually more delocalized electrons in the lattice than the one in sodium. So all of these things together increase the strength of the metallic bonding. So that means that melting and boiling point increases because there's more energy needed to overcome the metallic bonds. So let's have a look at an exam question which asks us about this. So it says the melting point of magnesium is much higher than the melting point of rubidium, and they want you to explain the difference. So you need to say something about the difference in charge and also something about the difference in radius, and then pull these two things together to explain why this has a consequence on the melting point. So there's different ways in which you could say this. I'm saying it in a slightly more expanded way. In their metallic bonds, Mg2 plus ions exhibit stronger electrostatic attraction for the delocalized electrons than rubidium ions do, and therefore more energy is required to overcome the metallic bonds in magnesium. The actual mark scheme is a bit more succinct. So the idea of ionic radius and charge together is your first mark. The ORA, that stands for or reverse argument. So you could say, for example, magnesium has a smaller ionic radius and a larger charge. And then rubidium's bonds are weaker and require less energy to break. So connecting it to the idea of melting is the second marking point. Okay, thanks for listening. Until next time, see you soon.